I have these two salt water solutions, and the solution in beaker B has more salt dissolved in it. There is equal amount of water. So let me write that. There is equal amount of water in beaker A and B, and there is more salt in beaker B. There is more salt over here, and you can see that in the way I have shaded it, so it's more cloudy and this one is less cloudy. There is more salt dissolved in beaker B compared to A. We can go more technical. We can say that this solute is more in the second beaker compared to the first one, even though the amount of solvent is the same, solute is more. But is there a shorter or a briefer way of describing what we are seeing? Well, turns out there is, and we can talk about concentration of a solution. We can talk about concentration of a solution. In this example, we can say that the second beaker, beaker B, is more concentrated than beaker A. Beaker A is less concentrated than beaker B. Or we can use the words dilute and concentrated. We can say that this is a dilute solution and this is a concentrated solution. Now the word dilute or concentrated can only be used when you are comparing it with someone else. If you only had beaker A, you can't really use the word concentrated or dilute, right? Because you use these words when you are comparing it with something else. When you have two beakers, now you know which one is more concentrated, which one is less concentrated. Whichever one is less concentrated, that is called dilute compared to the other beaker. In this case, beaker A has a dilute solution compared to beaker B. Now concentration of a solution, it can be measured in two ways. One is mass by mass percent of a solution, mass by mass percent of a solution, and the second is mass by volume percent of a solution, mass by volume percent of a solution. So let's look at each of them. For the first one, mass by mass percent of a solution, we can say that mass of solute, and let's stick to the example of salt water. In this case, solute will be salt, solvent will be water. So mass by mass percent of a solution is mass of solute divided by mass of solution into 100. Let's take a quick example. So let's say if we are mixing, let's take 40 grams of salt, and we are mixing it with let's say 360 grams of water. And now if you want to calculate its concentration, the concentration of this solution, 40 grams of salt and 360 grams of water, and we want to represent it in terms of mass by mass percent, then we can use this relation and calculate it. So in this case, the solute is salt, that is 40 grams, divided by 40 plus 360, that is the mass of solution, right? Denominator is not the mass of solvent, but the mass of solution. So 40 plus 360. Both salt and water make up the solution, right? And this is then multiplied with 100. So if we work this out, this will be 40 divided by 400 into 100. This goes with 10 and this goes again with 10. So this is 10% mass percentage of the solution. And we can be more specific and write of salt water solution, 10% mass percentage of salt water solution. Now let's look at the second way of describing concentration of a solution, that is mass by volume percent of a solution. So for this one, we can calculate it by using this relation, which is mass of solute, divided by volume of solution, into 100. And we can take an example. Let's say we have a solution with 2 grams of sucrose, and we are mixing it in 200 ml water. 200 ml water, that's the volume. So if we want to represent the concentration in mass by volume percent of a solution, we can write this mass of solute is 2 divided by 200 into 100. This goes by 100 and this goes by 1. So this is 1% mass by volume percent of the sucrose solution. We have assumed one thing over here, that is when we add sucrose, there is no change in the volume of the water itself, right? So you might be thinking, wouldn't the volume of solution increase? But we are assuming that it has a negligible effect. So the volume of the solution is 200.